Top of the morning to ya. So our case study for today is on the screen right now. So this is actually a Medium article that I've written beforehand, but I'm not sure if I'm going to publish it as of yet. Yeah, but anyway, so we'll be looking at the traveling salesman problem with Google's OR tools. So if you don't know what the traveling salesman problem is, usually shortened to TSP, it basically asks the following question. So given a list of cities and distances between each pair of cities, what is the shortest possible route that visits each city exactly once and returns to the origin city? So TSP is a famous and popular optimization problem. It has a vast area of applications, and most of our modern era companies such as UPS, Amazon, or those logistics and delivery services companies, what have you, will make use of TSP solutions. But I guess strictly speaking, they'll be looking at the vehicle routing problem, which is a subset of TSP. The only difference is that the vehicle routing problem involves a fleet of vehicles, whereas TSP assumes you only have one vehicle. And for today's tutorial, we'll be just looking at the basic TSP solution. So yeah, today we'll be imagining that we are a startup food catering business, so we will have a set of delivery destinations made known to us prior to the day of delivery, so as to plan a route that starts from our kitchen depot, goes to each destination, and ends back at the same kitchen depot. So this route will be optimized to be either of the shortest distance or the shortest time duration required. As mentioned, also we will only have one food delivery van. Yeah, our goal for today is not to formulate an optimization algorithm. We don't want to reinvent the wheel because there already exists many pre-built solutions, and one of these solutions is included in Google OR tools. So we'll be using that in our code, and we'll be also using Google Maps API, specifically the distance matrix API, to make our solution more user-friendly and feature-filled. One more thing that we have to get out of our head before we can move on is to set up a billing method for our Google account. Now, I'm sure most of us have a Google account, but not everyone has a billing method linked to it, but we will need the billing method to utilize Google APIs. Don't worry too much about any billings because we will be sticking to the free tier and you will not be charged anything. So yeah, let's get started on the tutorial, and the first thing we want to do is to look into Google OR tools. So Google OR Tools is an open source software suite for optimization. So it has a lot of libraries, and part of these libraries are used to help solve the TSP. And in fact, Google has a very well written guide for the TSP. I will be providing links to all this documentation in the description below, so not to worry about that. So yeah, just do a good thorough digestion of this whole guide. So it's pretty long, but we are only interested up to this point here, so you can stop right before the drilling a circuit board. So one thing good about Google is that it gives us everything that we need, so that's excellent for us. But of course, the code will be specific to the example given, but we can still reuse a lot of the functions here and also modify it a little bit to suit our own needs better. So what you're going to do is you just want to copy the code sample, and then you want to open up your own IDE and paste it in. So yeah, paste the code in and save the file as a Python script. Before we continue, it is a good idea to create a new working environment. Now, if you don't know what environments are, they are basically separate working spaces for you to have for different projects. The reason why we want these separate environments is because more often than not, our code requires the installation of different libraries and modules. So for example, in our code here, we will be requiring the installation of OR tools. These libraries and modules have different versions, and sometimes they have dependencies on each other as well. So for example, library A version 1 might only work with library B version 2. And also the presence of some libraries may affect the workings of certain other libraries as well. So yeah, if we were to have all our libraries and modules in one single environment, it will be very difficult to keep track of the dependencies. That's why it is recommended for us to split our projects into their own dedicated environments. So there are different ways of creating working environments for Python. My preferred method would be to use Anaconda, and have a go at looking up Anaconda and perhaps implementing it in your solution if you don't already know of it. But yeah, so what I'm going to do is open up my terminal, and I am going to create a new Anaconda environment, and we're going to install Python to it as well. So let's wait for this to install. So now that it has installed completely, I will activate the environment. And since my code is saved on the desktop, so I'm going to change my directory to the desktop, and then I can run the code. So as mentioned, there will be a library that we need to install, and this library is the OR2s. So we are going to try and pip install OR2s. Just wait for it to install finish, and once done we can try to run our script again, and this time it should work. So we're going to try to improve on this code, and one of the first improvements that we can do is even suggested in the Google guide. So that would be to include the Google Maps API inside it. So that would be under this section here, so other ways to create the distance matrix, and we are going to want to use Google Maps distance matrix API. So just open up the link and let's refer to it. Again, we are going to want to read through this guide, so have a go and understand what each function does. So one more thing to take note of is that to use the API, we'll need the API key, and this is the part where I mentioned that we need to link a billing method to our Google account. So to know how to do so, just open up this link, and this page doesn't actually tell you how to get the API key. Instead, you want to open up this other link, so getting started with Google Maps platform. So it's a very comprehensive guide to getting the API key, especially if you're new to this. So just go through step 1, step 2, and step 3. Now the API key that we want to use is called the distance matrix API. So just take note of that and follow through the guide to understand how to activate, or rather how to enable, the distance matrix API key. And this page also gives you information about billing. So just to reiterate, so as far as this project goes, you will not be charged anything. So once you get your API key, remember not to share it with anyone, and we can get back to the guide. So let's go to the entire program. We're gonna copy almost the whole thing, but not the whole thing. So we're just gonna leave out the main function right here, and we're gonna borrow everything else. So copy the code, go back to the code that we already have. So just go ahead under the lines for OR2s and paste in the code. And you're gonna want to take note of line 10. So this line actually works for Python 2 but not for Python 3. So assuming you're using Python 3, then you're gonna want to modify this. So this is how you modify it to work for Python 3. So again, it's a good idea if you have already read through the Google guide to understand what all these functions do. But the one we are going to look into closely now is the create data function. So in here, you're going to want to replace this with your API key. You can also choose to replace these addresses if you want to, but I'm going to leave it as the example ones given. Also later on, we are going to change this again to make it even more user-friendly. So right now, the user has to go into the code and type in the address right here, and even include all these plus signs, but that's not as user-friendly as we want it to be. So our end goal is actually to have a terminal input, so the user will go into the terminal and type in the address as one would normally do when using like Google Maps. So yeah, and the next function that we will look at is the create data model function, and this function came originally from the TSP basic code, and in it we were to originally define the distance matrix by ourselves, but we no longer have to do that because we have the distance matrix API. So let's go ahead and get rid of this, and we want the create data model to be able to receive a distance matrix, so we are going to create this parameter right here called distance matrix, and we can input this parameter here. And next we are going to modify the main function, so we're going to want to add in a few more lines into here. So let's go back to the guide, and we're going to copy these few lines from the main function. So go ahead and copy it. We're going to go back to our code. We're going to paste it right at the top. Make sure they're indented properly. So let's go ahead and try to run this Python script to see the output. So I'm going to call Python tsp YouTube. So I have to import the request library. So we're going to pip install requests. Let's try to run it again. Alright, so I also forgot to change one part here, which is we actually renamed this as a pseudonym, so UR. We're gonna try to find for wherever URL lib is referenced and change that to UR, the two letters UR. So that's one, and that's actually all of it. So let's save it again. Let's try to run it. One more error. So these two lines have to be at the front of the file. I forgot about that and I apologize. So let's just fix that real quick. I changed my shirt. So after installing all the required libraries, I also added in my API key, which I can't show to you guys. But anywho, let's go to the terminal and run the Python script and see what happens. So the output is correct, but it doesn't really speak to you much. Like, we don't want to see the indexes of the destinations. We want something more user-friendly, and we want to see the full names of the addresses displayed for you in the output. So that's one. And the second thing that we also want is to be able to accept the inputs of the user via the terminal. So the user can type in the addresses that he or she needs into the terminal, and it will be retrieved by the code. But before we get to those, there is still one more thing that I want to do, and that is to add in the time duration matrix into the code as well. So if we go back to the guide, there is a section which talks about the travel time matrix. There is. So very simply, it just requires you to replace distance with duration in the function. So we're going to do just that. So okay, the build duration matrix is done, and the next step is actually to go back to build distance matrix and find out the locations of wherever it is called in the code. We want to do this because wherever build distance matrix is called, we're also going to want to have build duration matrix to be called in the exact same location. So let's go ahead and find where it's being called. It seems that it's only called in this function right here, so under create distance matrix. So we're going to change this as well. So as mentioned, we're going to copy wherever we see for build distance matrix and do the same for duration matrix. So I'm going to copy this line here, change it to build duration matrix, change the variable here to duration matrix. We also need to initialize the variable, so up here, and then we want to repeat it for down here too. Now obviously we have both the distance matrix and the duration matrix now, so I want the function to return the two of it. Should be a comma here. And I also want to go back to the name of the function and change it to something more appropriate. There we go. Now since we have changed the name of this function, we also want to go back and ensure that it is being properly called in the main function. So this line over here, we need to call the correct name of the function. And also we now have two variables being returned by the function. So the first one is the distance matrix and the second one is the duration matrix. So over here on this line, we realize that create data model function takes in the distance matrix, but we don't want to leave out the duration matrix. We don't want to leave it lonely. So let's have this function take in two parameters, and we will go back to create data model function here and also update it accordingly. So we will create a new key called duration matrix, and the parameter duration matrix will go into it. But that's not all. Below that, we'll see that everything from here to here includes distance matrix, and we want to do the same thing for duration matrix. So we're going to clone all of this and have it modified for duration matrix. So what I have done here is I've cloned the functions that I mentioned, and I have split them into distance functions and duration functions. So initially this was just manager and this was just routing and so on and so forth. I've added the term distance to it. So distance manager, distance routing, distance transit callback index, distance routing, and down here we have instead duration manager. So it's basically the same as above, except every instance of distance is replaced with duration. It's as simple as that. Now we're almost there. So right here we have the solution, and initially we have only one solution, but now we have distance solution and also duration solution. This would be distance routing and this will be duration routing. So we also have to print the solution. So previously we only printed the distance solution. Now we have to print duration solution as well. All of this will have to be their respective manager, routing, and solution. So let me get to that. So I have named them accordingly, and I have also added in the if statements. So if there is a distance solution and if there is a duration solution, then print out the respective solutions. Now obviously these two print functions do not exist right now, so we're gonna change that as well. So up here we have the original print solution function, so we're gonna copy it and clone it so that we can have both the distance solution and the duration solution. Now we're also gonna want to change the string for the output right here, so I'm gonna get to that right now. So what we have here eventually is for the distance function, we have the title route based on shortest distance, the output will be route distance, and for the duration function we have the title route based on shortest duration, and the output is the route duration. And let's go ahead and run the script right now, and voila. And if you observe the results, you notice that the two of them are not the same, and this makes sense because the shortest distance route may not necessarily be the fastest because of traffic, or maybe you're taking the highway or something else. So we'll finally get to making the code more user-friendly, and the first one will be to allow the user to key in the addresses that he or she wants. And first I'm going to explain how to get an input from the terminal. So I've created a new Python script here. You don't have to do this with me, this is just for demonstration purposes. I have two simple lines right here. So the first line is how you get an input from the terminal, and the second line will just print out whatever input that we received. So let's go into the terminal and run the script. So it's expecting an input right here, so I'm gonna just type school and it should print out school again. You can also add in a string inside the input function, and this string will appear inside the terminal, sort of like a title to your query. So let's run the script again. So it will ask me for an address, and I'll type in school and it will print school. Now we also want to have a way to allow the user to continuously give their input until they want to stop. So to do this, we can do a while loop, and I have chosen to do a while true loop, and technically this loop will go on infinitely until there is a way to break it. So in order to break it, the user has to type in done. So let's see how it works. So if we run this script, it'll keep asking me for an address, but if I want to stop, I can just type done. Now I'm still not too satisfied with how this looks like. I want the system to be able to recognize how many addresses I have given thus far, so this should show as address 1, address 2, and so on and so forth. To do this, I have created the variable num, and I want num to be referenced inside the input function, and for that to happen we need the curly braces as well as dot format, and whatever appears inside format will appear inside the curly braces. So num is an integer, and so the number will appear next to the word address. So it starts with 1 and it will increment accordingly while the loop goes on. Let's see how it functions. And so it starts out with 1, next will be 2, address 2, address 3, but I want to stop it, so that's how it works. So that about covers it for the basics, and if we go back to the guide, we'll notice that the address comes in a very unique format, so there are no spaces, and instead of them there are plus signs. So we want to replicate this format, and whenever the user types in an address, the user will type it in normally, but the code would morph whatever the user inputs into this specific format, and that can actually be done with one single line. So what we're doing here is we're calling the replace function, and we're gonna replace any white spaces with the plus sign. So let's see how that works in our terminal. So this time I'm going to give a longer address, so I'm going to type in high school with a space in between, and you see that the space has been replaced with a plus sign. And let's try another one. Maybe I'll try home office, and there we go. So that's about it as far as terminal inputs go. So let's go ahead and copy this code and have it inside our TSP code. I've gone ahead and done that. In fact, I've created a new function called received input, and this function is almost exactly the same as the input script, except there is a addresses list. So this list will store the user inputs in it. To do that, we will append the input inside the list, and obviously the function would return the addresses list. Of course, then we look down here into the create data function, and we notice that we don't need to manually type in the addresses anymore, so we're going to remove this. In fact, we're going to pass in the addresses parameter into the function and have this parameter used here. Once that's done, we need to go back down to our main function to be able to do all of this. So let's start at the beginning. We're going to get the addresses, so we're going to call the receive input function, and then these addresses will be passed into the create data function. Alright, so we can test out the code right now. So let's go to our terminal, and so I live in Singapore, so I'm going to give Singapore addresses that I'm familiar with. So I'm just going to type in some of the malls that I frequent. So click done, and you can see the results. Now let's work on fixing the output to be more user-friendly. So I want the names of my addresses in the output instead of these indexes. To do this, we will go back to the receive input function, and in here I've created a new list called labels. This list is different from the addresses list because it's going to store the addresses before they are being modified. If you remembered, we modified the address input to replace the spaces with plus signs. Now we don't want to display the modified address as our output because that won't be very meaningful and it won't look very nice. So I'm going to append the input to the labels list before we modify the address. And of course, at the end, we also want to return labels list. And also we'll go back to the main function, and we'll update this accordingly as well. So the receive input will now give us two lists, so one of which is the labels list. These will go into the print solution functions. So let's add in a new parameter for the two functions called labels, and we'll update the functions itself accordingly. So to modify this function to output what we want is a little tricky, but we just need to understand what this line does. So this is where the index of the destination appears. So for example, we have 0 dash dash arrow, then 1 dash dash arrow, then 2, and so on and so forth. So also, if you remember what dot format does, is whatever appears inside this bracket will appear inside the curly braces. So manager.index to node index actually gives us the index of the destination. So we know the index of our destination. We can now go into our labels list and reference the index to call upon the exact name of the address. And that's it actually. So let's also do that for the duration function. And also for this line here in one last spot. So that is all you need to do. And if we go back to our terminal and try this out, so I'm gonna give the same addresses I used earlier. Let's see what the output is. And there we go. So is that all? I'm afraid that's not entirely all. So I don't know if you noticed this, but I bet you did. Yeah, so this print statement actually appears before you even call the route distance. So it does not actually print route distance or route duration. So yes, slight oversight on my part. So to rectify that is very simple. You just bring down the print statement and this should do it. I also did not change this to route duration, so let's go ahead and fix that, shall we? Thankfully, the name of the variable did not affect the output in this case. We just want to make sure that everything is standardized and properly named. So let's go into our terminal and run the script again, and we're going to key in the same addresses. And yeah, so this time it correctly shows me the full output. So it gives me the distance and also the duration. But hang on. Again, I'm not too satisfied with this output. First of all, what the heck is 1481? This is actually in seconds, and you can find this out in the API documentation. Secondly, I also want to include the route duration for this particular shortest distance route. At the same time, I also want to include the route distance for this particular shortest duration route, just to make everything more robust, more feature filled. So yes, let's get right into that. So let's go ahead and change the easiest part, which is to modify the route duration, which initially is displayed as seconds, but we are going to change this to display it in hours, minutes, and seconds. So to do this, we want to call upon datetime. So datetime is actually a library which we also need to import. So let's go up to here and import datetime. And then we want to include the duration routing in our distance solution. So we're gonna have to add in duration routing as a parameter. And for the duration solution, so we want to add in distance routing in this case. And of course, we will then go back up to our function right here. This time we're going to have to define both the distance and duration routing separately. So let's do that as such. So inside the function, we're going to add in what we had for distance, only this time for duration. So I have route duration here. I also have the route duration cost, and of course the route duration output. Now also be careful that we have to specifically define that this index is following the distance routing, also in this line over here and also in this line here. And the same thing can be said for the duration solution, except the other way around. So we have route distance here, we have the route distance cost, and also we'll be printing out the route distance. Hey guys, apologies. So I actually made a mistake here. So this should be duration routing parameter and this should be distance routing. The reason why is because I actually referenced duration routing first. And now we'll get to the terminal to run the script to get our final output. So this is our final output, and voila. So that's all I have for you in this tutorial. I hope you've learned something new today and that you enjoyed yourself. Thank you for tuning in, and I'll see you in the next one.